So in the last two class, we have discussed about the inductive effect and resonance effect. Resonance effect. Okay. Resonance effect. Then what are the kinds of resonance effects is there? That is the positive resonance effect and negative resonance effect. Positive resonance effect, positive resonance effect, and negative resonance effect. Okay, negative resonance effect, negative resonance effect. Okay, now, and we have discussed about some of the example of the positive resonance effect, negative resonance effect, that is called as a plus R effect or minus R effect in case of, and also we have discussed about the electromeric effect, electromeric effect. Also we have discussed about electromeric effect and in case of electromeric effect, we have also seen there are also two cases, whether one will show the positive E effect, that is in the short effect, positive effect, positive E effect. Okay, and also negative E effect also is there, negative E effect. So we discuss all this effect with the some of the examples. Now in this today's class, so what we will discuss? We will discuss about the stereochemistry. So what is stereochemistry? So let's say we start from the beginning. So stereochemistry. Okay. So stereochemistry. So first we discuss about what is the definition of the stereochemistry. Okay. This is one of the most important topic in the organic chemistry. So in stereochemistry, what is the definition? So the branch of chemistry which deals with the three-dimensional structure of molecules and their effect. So what will be the definition? So the branch of chemistry, the branch of chemistry which deals with which deals with deals with three-dimensional structure, which deals with three-dimensional three-dimensional structure, three-dimensional structure. Okay, and structure of molecule, three-dimensional structure of molecule, structure of molecule, and their and and their effect on physical and chemical properties. Physical and chemical properties is known as stereochemistry. Is known as the stereochemistry. To represent molecule as a three-dimensional object, we need at least one carbon sp3 hybridized. So what is the main important point in the stereo to define a stereochemistry of a carbon center? So the main thing is that we need we need at least we need at least one carbon sp3 hybridized. Okay, so we'll go to the example. Now, what will be the example? So let's say we'll discuss about an example of. So this is, let's say this is a hydrogen. This is a carbon center, and three other arms is connected with, one is chlorine, one is bromine, and another one is iodine. This is a 2D drawing. 2D drawing, not appropriate, appropriate, not appropriate, not appropriate for stereochemistry. Okay. Now we need a 3D drawing. which can define a molecule in three-dimensional manner. So now let's say if we start from the now if we represent in different way, like the same molecule, if we define, if we represent in this way, hydrogen, iodine, and the chlorine will be and below, and the bromine will be in the above position. Then it will be the 3D drawing appropriate for the stereochemist. Now it is the appropriate for actually the stereochemist. Okay. And this is the main three-dimensional representation of the previous molecule. Now we will discuss about the isomers and their classification. So terminology that used in the stereochemistry. Now terminology used in stereochemistry. Okay, isomers, isomers and their application. Okay. So what are the, so you are already familiar with the concept of isomers. So different compounds which have the same molecular formula. Here we will learn to make distinction between various kinds of isomers, especially the stereoisomers. Okay. So now the what are the isomers are possible? Isomers. So what is actually isomer? So different compounds with same molecular formula. So we start from the, let's say, isomers. So if we start from the isomers, isomers is what? The same, oh, different compound with same molecular formula, Okay. Now we will divide in two way. So one is the constitution in isomers and another one is the stereoisomers. So the first one will be the constitutional isomers and the second one is the stereoisomers. So isomers with a difference in 3D arrangement only. Isomers with a different 3D arrangement only. Isomers with a different 3D arrangement only. That is called different 3D arrangement only. That is the a short definition of the stereoisomers. And the constitutional isomers or structural isomer is the isomers differ in the connectivity of their atoms. So the isomers differ in connectivity. Okay, connectivity by atoms. Now the stereoisomers can be divided in two ways. The stereoisomer can be divided in two ways. So one is the conformational isomer and the second one is the configurational isomer. So one is the conformational isomer, and the second one is the configurational isomer. Configurational isomers. Conformational isomers. Okay. So the conformational isomer is what? So isomers which which are readily converted into each other through a single bond. So that is called the conformational isomer. So isomers which are readily readily converted into each other through a single bond. Isomers which are readily converted into each other through a single bond. Now, configurational isomer is the no rotation possible through a single bond. So this is the conformational isomer. Okay. Now, configurational isomers is the no rotation. No rotation possible. Okay. Now, configurational isomer is also two-way. So one is the geometrical or cis-trans isomer, and the second one is the optical isomer. So the configurational isomer can be divided in two way. So one is the geometrical isomer, geometrical or cis-trans isomer, cis-trans isomer, and the second one is the optical isomer, optical isomers. Okay. Now we will discuss about what is optical activity. So the optical activity is the we know that the ordinary lights are composed of a ray of different wavelengths vibrating in all directions perpendicular to the path of its propagation. So this vibration can be made to occur in single plane by passing ordinary light through the polarizing nickel prisms. Okay, so such light whose vibration occur in only one plane is called the plane polarized light. Okay, so if the compounds, so in this plane polarized light, so in this plane polarized light, in the plane polarized light, so if the compound rotates the plane of polarization to the right, means the clockwise, it is said to be dextro-rotatory. Okay, so it is also denoted by plus or D. So what is dextro-rotatory? Dextro-rotatory, rotatory. So dextro-rotatory. So if the compound rotates the plane, rotates the plane of polarization to the right, that is clockwise, it is said to be dextro-rotatory. Okay, dextro rotate dextro-rotatory. Okay, now we'll discuss about the levo-rotatory. If the compound if the compound rotates the plane of polarization to the right, sorry, to the left, that is clockwise, it is said to be levorotatory. Levorotatory. Okay, it is also denoted by negative or L. Now, the change in the angle of the plane of polarization is known as the optical rotation. So what is optical rotation? Optical optical rotation. So what is optical rotation? Optical rotation is the change in the angle of plane of polarization. The the change in the angle of polarization is known as optical rotation. Okay, the optical rotation is detected and measured by an instrument. So in which instrument the optical rotation can be measured? It is called as the polarimeter. The instrument known as the polarimeter. Polarimeter is the instrument which measure the optical rotation, which measure the optical rotation. Okay. So this is called the polarimeter. Now, the measurement of optical activity is reported in terms of the specific rotation. In terms of the specific rotation. So, what is specific rotation? So, specific rotation is denoted in by this. This is the formula. This is the alpha, where lambda T temperature equals to alpha alpha y L and C. Okay. So alpha is the specific rotation. So this is the specific rotation. This is the specific rotation, and the T is the temperature. Okay. And lambda is the wavelength of the wavelength wavelength of the light used. Okay. Then this is the observed rotation. This is the observed angle of rotation. Observed angle of rotation. Now the L is the length of the rotation. Length of sample tube in length of sample tube. Okay. And the C is the concentration. C is the concentration of the sample, and the C is the concentration concentration of sample in gram per ml of solution. Okay. Now we'll discuss about the chirality. So what is chirality? Chirality. The term chirality, actually the word chiral is used for those objects which have right-handed and left-handed forms. That is the molecule which have handness, and the general property of the handness is termed as a chirality. An object which is not superimposable upon its mirror image is called chiral. So the molecule and objects, let's say, if we see the definition of the chiral molecule, so in objects, an object so which is not superimposable, which is not superimposable upon its mirror image is called chiral molecule. Okay. Now we'll go to the example. So the term asymmetric center and the chiral center. So three terms are used to designate a carbon atom bonded tetrahedrally to four different substituents in a chiral molecule: asymmetric atom, chiral center, or stereo center. Okay. So the term is can be defined in such a way that the asymmetric atom or chiral center or stereo center. Okay. So if we see the example, let's say A, and this is D, and this is B, and this is C. Now this is the one that this carbon center is the chiral center or stereo center or asymmetric carbon. Okay. This can be defined in such a way. So now we'll discuss about the some of the example. Okay. Now if we start from the CH3, this is a chlorine, this is a hydrogen, and this is a bromine. So this carbon center is the chiral. Asymmetric has four different atoms bonded to the carbon center. Okay. So asymmetric, this is a chiral. Asymmetric has four different four different atoms bonded to four different atoms bonded to carbon. That is why it is a chiral asymmetric center. This is a chiral molecule. Okay. This is a chiral molecule. Okay. Now we'll discuss about one achiral molecule, which doesn't have the four different atoms bonded to the carbon atom. Okay. So if we discuss about, let's say, CH3, and here it is bromine is there, but if we replace one of the chlorine atom to a one hydrogen atom, then this hydrogen is the same. Let's say this is a carbon center, but this is the different. Br is the different, CH3 also different, but these two hydrogen is the same. So this is a chiral molecule. Okay, a chiral molecule which doesn't have four different atoms, does not have four different, does not have the four different atoms bonded to carbon, bonded to the carbon. Okay, now another chiral center we will discuss. Now we'll discuss the molecule which have two chiral centers. That means more than one chiral center. Let's say if we talk about CHO, one is OH, hydrogen, another one is also OH and a hydrogen, and this is also CH2OH. So two chiral center is there. One is here, another one is here. Okay. Now chiral with two chiral center. With two chiral center. Okay. Now we'll discuss. This is a two chiral center containing one molecule. Now if we see the another example where the molecule contains more than two chiral center, that means let's say for an example three chiral center. So that is, let's say CHO, and one is the OH is here and hydrogen is here, then another OH is here, this is also hydrogen, two chiral center. Now it is a three chiral center, OH here, hydrogen here, and this is the CH2OH. Now this is here is three chiral center, one is here, another one is here, and the third one is here. So three chiral center, chiral with three chiral center, conjugative chiral center, chiral center. And chiral centers, important point to be noted. So chiral centers are shown by star. Now interchange of the atoms. So the term stereogenic center or the stereo center, a stereogenic center is defined as an atom or which an interchange of any two atoms or group results in a new stereoisomer. When the new stereoisomer is an enantiomer of the stereoisomer is the called chiral center. Okay, all stereo centers are not tetrahedral. The term stereogenic center or the stereo, the term now we'll discuss about the stereogenic center or stereo center. Let's say if we take an example COOH, and here OH, hydrogen, and here it is a CH3. Now if we interchange the hydrogen and OH, now if we interchange the position of the interchange the position of interchange the position of hydrogen and OH, then we will get the new stereoisomers. COOH, OH is here, hydrogen is here, Just we change the position. OH was the right side. We change the position OH to the left side, and the hydrogen was left side initially. And the product we are getting, the let's say hydrogen is coming to the right side. So we just change the position of the hydrogen as the OH group. Now we will get the new stereoisomer. So this is the new stereoisomer. Stereoisomer. Okay. This is the structure 1 and structure 2. So these two structure, one first and second, is a enantiomer. Hence the stereo center is a chiral center. So this is called, hence the structure 1, the structure 1 and structure 2 is called enantiomer. This is the new term, enantiomers, as they are non-superimposable mirror images, as they are non superimposable mirror images. This is also the stereo center. This is also, you can say, is a chiral center. This is also, you can say, is the chiral center. This is also, you can say, is a chiral center. Okay. Now we'll discuss about cis trans isomer or geometrical isomer. If we talk about one example, here you can see this is the alkene part. This is a C double bond C. So in one side, both the same group is present, and in another side also same group is present. So that is why it is known as the cis isomer. And now if we change the position of CH3 and hydrogen, now CH3 and hydrogen, what we'll get? We'll get the CH3, hydrogen, CH3 and hydrogen here. So now this the same molecule in the opposite to each other. This is called the trans isomer. Okay. So next class we'll discuss some other topics. Thank you.